Hello, in this video I'm going to solve the following problem for you. Evaluate the following integral. Integral of t times dt all over t plus 1 times t squared plus 1 squared. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, one possible answer that you will get is as follows. 1 over 4 t minus 1 t squared plus 1 minus 1 over 4 times ln of absolute value of t plus 1 plus 1 over 8 times ln of t squared plus 1 plus a constant c. Okay, now let us solve the problem. So the integrand that you see here is a rational expression, and the degree of the numerator is 1, the degree of the denominator is 5, so everything is in order. I can immediately start the method of partial fractions. So the fraction that I have here is t over t plus 1, and then I have t squared plus 1 squared. I want to split it into partial fractions. The first factor is t plus 1 is a first degree 1. So in the top, I write just a constant a. For the next one, I see that this is a second degree polynomial that cannot be factorized more. And then I have a power of 2. So I have to write two fractions for it. Once for t plus 1, t squared plus 1, and one for t squared plus 1 squared. So here, these are quadratic terms. So what I write here is a first degree polynomial in its general form. So I have used the letter a here. I start with b times t plus c, and here I will say dt plus e. Then I have to fine tune these numbers so that this becomes identical to that one. Okay, but for the first ones, I can use a trick to do it. Of course, I cannot use the trick that I want to describe for these cases, but still here I have 1, 2, 3, 4, 5 unknowns. At least I can get rid of them very fast. So how is that? I will ask myself, what makes the denominator here 0? The answer is t is equal to minus 1. So I will take this off from here and replace t with minus 1 everywhere. This is one of the questions in the previous sections to prove this will work. So let me use that, okay? I will refer to the problem in Adams below this video. Okay, so I put minus 1 here. So the answer is minus 1 over 4. So it's minus 1 over 4. So I already know a is minus 1 over 4 according to this rule. So let me repeat. The one that makes the denominator of a 0 is t equals to minus 1. You go there and take that factor off, and in the remaining, replace t with minus 1. So the numerator is minus 1 divided by 2 to the power of 2, 4. So a is minus 1 over 4. Then I can look for the other 4 unknowns. So what I have to do, I have to multiply everything by this denominator. So of course the left-hand side becomes simply t. The right-hand side, what happens, this one and that one are gone. A, which is minus 1 over 4, will be multiplied by this leftover. Yes? The next one will be bt plus c. When I multiply this by that, this will cancel one of these factors, so these will go into the numerator. So what will happen, it becomes t plus 1, another t squared plus 1. So the calculation is a little bit lengthy, so we have to be patient here. And then when I multiply this by that, this one and that one are gone, t plus 1 is left, which will be multiplied to the numerator. Yes? Yes, and now I have to expand. So I will only expand the right-hand side, keeping this. So it's minus 1 over 4. So this becomes t to the power of 4, 2 times the first one times the second one, plus the second one squared. And here I have to do it in 2 steps. So let me multiply these two first. So it becomes t cubed plus t squared plus 1. And then let me multiply that. So it becomes dt squared plus dt plus et, and finally plus e. I have to multiply once more here. So I multiply minus 1 over 4 inside as well. Minus a half t squared minus 1 over 4. And then this becomes b t to the power of 4, b t squared, b t cubed. And then I have bt ct cubed, ct squared, and then I have c. Yes? And then I copy and paste the rest. Oh, this is not E. This is, oh yeah, that is, let me see. Yeah, that's E, yes. Yes, that's E. And then I collect them. So what happens? I have a minus 1 over 4. This is t to the 4. I have another t to the 4 here. I factor it out. So this is what is left for me. Then let me go to the cubic term. So I have a t cubed here. Okay, so I have a b here. I have a c here, and that's it. Am I right? So let me cross them over not to get confused. So this one I considered, that one I considered, this t cubed I considered, this t cubed I considered. Okay, then I go to the quadratic terms. So how many quadratic terms are involved? So I have minus a half here. I considered that one. I have a b here. I considered that one. And then I have a c and d. So I considered these two as well. Then I have to go to the first degree terms. So nothing is left here except b. And then I have a c. So I cross them over. And then I have a d and an e. I cross them over. And then what is left for, oh sorry, this is a t here. And then what I have are constant numbers. So you see there is a minus 1 over 4 here. E, let me write e first. And c. Yes. Check the list. Minus 1 over 4. That's it. Okay, so this should be identical to this polynomial. This can happen if and only if the corresponding coefficients on the right and the left match. So this means that this number is 0. So it means that b is 1 over 4. Yes, because this should be 0. This should also be 0. So this means c is minus b. So c is minus 1 over 4. Yes. And then here, this should also be 0. So let me write it. Minus a half. B is 1 over 4. Yes. C is minus 1 over 4. And D is still not known. But the answer should be 0. So this means that D is 1/2. Yes. And then I go here. This should also be 0. So B, C, D plus E. But I already know all of them. So b plus c is already 0, so e is minus d. So it means that e is negative 1/2. Yes? And then finally, this, oh, sorry, it shouldn't be 0. That was my mistake, sorry. Why? Because this is the first degree polynomial, this is the first degree term, and this should match with that one. So let me write it here. So this plus that is already 0. D is 1 over 2. E is still not known, but because this is the coefficient of t, that should be 1. So this is 1. So again, this gives me, of course, e is equal to 1/2. Yes, so these are the numbers that I have got so far. And then these are all 4 variables that I needed. Okay, so now the integral of this is these 3 integrals that I have to calculate. Integral the first one, plus the second one, plus the third one. So if you don't mind, let me call this I. So my integral I is now equal to, A is minus 1 over 4, I pull it out, integral of dt over t plus 1. The second one, look, I have B and C here. But B and C are 1 over 4 and minus 1 over 4. So it will allow me to factor a 1 over 4 out. Yes. So here T will be left. Here minus 1 will be left. D divided by t squared plus 1 dt. And the third integral, I have d and e. They are each 1/2. I factor 1/2 out, and then I am left with t plus 1 divided by t squared plus 1 squared dt. Okay, so then I have some integrals to consider. This integral is extremely simple because the answer to this is just ln of absolute value of t plus 1. This, I can break it into two integrals. One integral of t over t squared plus 1 dt minus integral of 1 over t squared plus 1 dt. But this is just by a substitution method. This t is the derivative of the denominator up to a scaling factor of 1/2. So this becomes 1 over 2 ln of absolute value of this expression, but that doesn't need an absolute values because it is positive. And this is a famous integrand, and that is arctangent. So that is tangent inverse of t. Okay, so very simple. I was able to find these three integrals. I have to combine them at the very end. So let us try to analyze that problem. That problem is also simple. So what can we do? So let me call this integral j, and let me calculate j here. Okay, so integral j is equal to the integral of t plus 1 divided by t squared plus 1 squared. Okay, so and dt. What can I do? I can split this integral into two integrals, t over t squared plus 1 squared dt, and then plus 1 over this. So if I would write it as dt over t squared plus 1 squared. So now, in order to answer j, I have to calculate this integral and that integral. But that is also simple. For example, here, I can take t squared plus 1 to be u, and then it means that 2t dt is du. So this integral, so if you don't mind, let me call it k. So integral k becomes equal to, instead of t dt, I put 1/2 du, I pull 1/2 out, it becomes du, divided by u squared, because I took this u. And this is a famous one. It's minus 1 over 2u, and then I replace u with what I have, so it becomes minus 1 over 2 t squared plus 1. So that is also k. So if you don't mind, let me call this, let me write k here for future in a package. So this is my k. Yes? And then for that one, let me call it, for example, L. So the only thing we have to do is to calculate L. So that's probably the harder part, which needs a trigonometric substitution, yes? So what I will do, I will concentrate on calculating this integral L, t squared plus 1 squared, and that's a famous trigonometric substitution. I have to introduce a variable theta to be tangent inverse of t. So this means that tangent theta is equal to t. On the other hand, because theta is the value of an inverse tangent function, it lives in the fourth or the first quadrant, yes? So in the fourth or first. It means that theta is somewhere between minus pi over 2 and pi over 2. Okay, but I also need dt, so it motivates me to differentiate t. So the derivative of tangent is secant theta squared and then d theta. So then integral L can be written as what? Integral. Instead of this, I write secant theta squared d theta. And in the denominator, I would write tangent theta squared plus 1 to the power of 2. But let me simplify this. It becomes secant theta squared d theta divided by this expression, which is secant theta squared, another power of 2, secant theta to the power of 4. So then I simplify it, it becomes integral 1 over secant theta squared d theta, but then it becomes cosine squared theta. Yes, because secant is 1 over cosine. And this is a very standard integral, so I use the double angle formula, so it becomes 1 plus cosine 2 theta over 2 d theta. I split it into two parts, so it becomes integral of 1 over 2, which is 1 over 2 theta. And the other one becomes 1 over 2 sine 2 theta. There is also 1 over 2 here, so it becomes 1 over 4 sine 2 theta. But theta is not a good variable. I have to switch back to my old variable, t. How can I do that? So let me continue here. For t, I do not have any for theta, I do not have any problems. But for this one, I have to do some calculations. What can we do? So here, I can continue. So let me write it down here. So sine 2 theta is equal to 2 sine theta cosine theta. Yes. Of course, you can use what is mentioned in Adams by drawing a triangle. So that also works here as well. So if I have this one, if I take theta to be this and this one, and then of course you immediately realize, and then let me take this one to be t and this one to be 1. Why? Because in that case, tangent becomes the opposite side divided by the adjacent side. And then, of course, if you ask me what this is, the answer is just simply t squared plus 1 square root. Okay, so then this becomes 2 sine theta, which is this divided by that, multiplied by cosine, which is 1 divided by that. Yes? And then what happens? So this becomes 2 divided by 2t divided by t squared plus 1. So that is your sine 2 theta. So if you combine all of them, L becomes equal to 1 over 2 theta, which is 1 over 2 tangent inverse of t, and then plus 1 over 4 multiplied by your sine 2 theta, so it becomes 1 over 2 t over t squared plus 1. And that is the L integral. Okay? So if I haven't missed any points, hopefully, we should be able to combine everything back in that formula here. So let us keep track of everything together. So here, this is my I is equal to, I have minus 1 over 4 times that. Okay, and then 1 over 4 multiplied here and there. So this becomes 1 over 8 ln of t squared plus 1. 1 over 4 multiplied here. Yes. What more? I have my j. Remember, I have a factor of 1 over 2 that I have to multiply by my j. When I multiply my j by 1 over 2, my k will be multiplied by 1 over 2. This is my k, so it becomes minus 1 over 4 t squared plus 1. Yes, and then of course, because I multiplied my j by 1/2, this will also affect my L. This is my L here, so I multiply it by 1 over 2 again, and then this becomes plus 1 over 4 tangent inverse of t plus 1 over 4 t over t squared plus 1. And of course, I can add a constant at the very end. Okay, so this is the answer to this integral, but I have to simplify it, if possible, to what we had in the answers. Yes? So let me see what the answer was. Okay, so for example, here you can see that this one, whatever it is, and that one are gone. If I want to write everything in order, so I have so according to the problem, I have this factor as the second term. So I just want to make sure that I haven't done any mistakes. So I wrote this here in this location. And the next one is plus 1 over 8 ln of t squared plus 1, which I have it here. So I considered this one, I considered that one. So in principle, I should be able to combine these two. And that's also extremely simple because you see that the denominators are the same. So what I would write 4t squared plus 1 here. And then I have a t here and minus 1 there. Yes? And then I have a constant c. So let me just double check with the answer. Yes, of course, in the answer that I provided, I put 1 over 4 outside here. But that's the same story. So 1 over 4 times t minus 1, t squared plus 1. And I don't need a pair of brackets anymore here. Yes? And then minus 1 over 4 ln of t plus 1. Yes, everything is in order. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.